In this video, we are going to talk about formally defining what a scale factor is and how it is used. So the first thing I want to do is define what a scale factor is. So a scale factor is basically a number that describes how much you are enlarging or reducing an image. So it's describing if you're making the image bigger or if you're making the image smaller. But the key thing to note here is that it's just a number. So let me write that definition down. A scale factor is a number that describes how much you reduce or enlarge an image. Now I'm going to list a few examples. So when I say an image, I mean things such as a map. I could mean things like a blueprint or a picture. So once again, the key thing to take away from this definition is that a scale factor is just a number. So if you want to go ahead and circle that or underline that in this definition, the key thing to note here is that a scale factor, whenever we're talking about a scale factor, we're just talking about a number. So here are some quick tips about scale factors. When the scale factor or the number is greater than 1, that means that the image you are taking is being enlarged. And when your scale factor is between 0 and 1, typically what I mean is less than 1, but you never have negative scale factors. But when the scale factor is between 0 and 1, the image is being reduced. And then when your scale factor is exactly equal to 1, the image stays the same size. And you might remember that when you have two figures that are exactly the same size and shape, that is referred to as being congruent. So if you take an image and you scale it by a factor of 1, you're basically just keeping it the same size and same shape, so it would be a congruent shape. Last thing I want to note is that there are 3 different ways to represent scale factors. You can either represent your scale factor as a whole number, or if it's between 0 and 1, it would be a fraction. The second way to represent a scale factor would be as a decimal, and the third way would be to represent your scale factor as a percentage. We saw an example of this on our homework the other day, where they were talking about the stars, and they were saying that the scale factor was either 0.25, 1/4, or 25%. So let's practice using scale factors down below. In number 1, it says, let's say you scale a figure by each given value of r. Will the new figure be smaller, larger, or the same size as the original figure? So basically what they're saying is that r in all of these cases is representing the scale factor, and we need to know, is that scale factor going to make the image bigger, smaller, or make it stay the same? So the first scale factor is a scale factor of 1/9. So I would maybe recommend typing in your calculator, just making sure that this is less than 1. 1 divided by 9 as a decimal. Okay, so that's going to be 0.1 repeating. That is clearly between 0 and 1, so that's going to make my image smaller. The next scale factor is a scale factor of 0.92 or 92 hundredths. This is also between 0 and 1. It's very clear to see, so it's going to make my figure smaller. 10/3. 10/3 written as a decimal, if you're not sure if it's greater or less than 1. So that's going to be about 3.3 repeating, which is greater than 1. So this is going to make my new figure larger. And then when finally I have a scale factor of exactly 1, that means my new figure will just be the same size. So let's go on to number 2. Number 2 wants us to label whether the two scalings are either the same or different. So number 1 says that is asking if we scale by 2, is that the same thing as scaling by 1/2? Well, scaling by 2 would make it bigger, and scaling by 1/2 would make the image smaller. So this is definitely different. The next says scaling by 1/3 and scaling by 30%. This one might be a little tricky. Let's see what 1/3 is represented as a decimal. So I'm going to do 1 divided by 3. So moving the decimal over 2 places, 1/3, that's actually 33.3 repeating percent. So even though they're very close, they're both in the 30 area, they are not the same scale factor. So therefore, this is still a different scale factor. Scaling by 1/3 and scaling by 30% are not the same thing. The next one is asking about the scale factor of 3/5 and scaling by 6/10. Well, let's see what 3/5 is as a decimal. And we see it's 6/10. So 3/5 is 6/10, and 6/10 is the other scale factor they're asking about. These are the same. And lastly, scaling by 1 and scaling by 100%. Both are ways to represent one whole. Scaling by 1 and scaling by 100%, that is the same exact thing, and it's actually going to keep the image as the same size. So that concludes the front page. We did a lot of basic definitions and a lot of working with scale factors written as numbers. Let's apply that on the back. So let's flip your page over to the back. And the back page says we have 2 triangles. They are graphed on the coordinate XY plane. And it says the smaller red triangle is scaled to create the larger blue triangle. And they're asking what's the scale factor. So let's just take a look at some of the dimensions. When I say dimensions, I mean the length of the sides. So the smaller red triangle has a height of 1, and it has a base of 2. And I'm doing this just by counting the boxes. So 2 boxes for the base, 1 box makes the height. And then let's do the same for the blue triangle. So the height is going to be 2 units. And then for the base, I have 4 units. So just looking at the dimensions, it becomes very apparent that you're taking each dimension and you're just scaling it or multiplying those dimensions by 2. So what is the scale factor? Well, the scale factor is 2 because I just multiplied the dimensions of the smaller red triangle by 2, and I resulted in that larger blue triangle. Next question asks, what's the perimeter of the small triangle? Well, this brings us back to an old topic of perimeter. Perimeter means take all of the sides and add them up. Well, we know this side is 1, we know the base is 2, but we don't know the hypotenuse. However, you can easily and quickly solve for the hypotenuse by using Pythagorean theorem. We'll call the hypotenuse x. 1 squared is 1, 2 squared is 4. 1 plus 4 is 5, and that equals x squared. You square root both sides, and you get x is the square root of 5. So that means the hypotenuse is square root 5. So if I want to add those 3 sides together, you would say, well, what's 1 plus 2 plus the square root of 5? Well, 1 plus 2 is 3. And then when you add that to the square root of 5, you can't really combine them because the 5 has a square root symbol over it. But let's see what that comes out to approximately be in our calculator. So I'm going to take 3 and I'm going to add it to the square root of 5. and I get about 5.2, let's just say 5.2. Okay, then they ask, what's the perimeter of the large triangle? So again, we have the base and the height, but we don't know the hypotenuse. So let's use Pythagorean theorem. We'll call the hypotenuse x again. So 4 plus 16 gives me 20. 20 is x squared. Square rooting both sides, we get x is 20. Square root of 20. So the hypotenuse of the blue triangle is square root of 20. When I add that all up, 4 plus 2 is 6. 6 plus root 20. And I want to write that as a whole number, so going to my calculator, 6 plus the square root of 20 gives me about 10.4. So the next question is asking, what's the scale factor of the perimeters? So to get from the perimeter of the red to the perimeter of the blue, it looks like we just multiplied again by 2. So when you scale an object by 2, you're scaling all of the sides by 2, the perimeter also gets scaled by 2. So let's try now doing this for the area. Area should be quicker. Area is just base times height divided by 2. So for the small triangle, base times height divided by 2 gives you an area of 1. For the bigger triangle, base times height divided by 2. I'm sorry, I meant to do that in blue because it's a blue triangle. Base times height divided by 2. That gives you 4. So now it's asking, well, what's the scale factor of the areas? Well, for the area, we went from 1 to 4. So we actually multiplied the smaller red triangle's area by a scale factor of 4. Now this is interesting. The scale factor for the area was 4, while the scale factor of the perimeters was just 2. The reason this is happening is because when we scale area, area is units squared. So we're actually taking the scale factor and squaring that scale factor. And when you square 2, you get 4. So perimeter was just in 1 dimension, so if the scale factor was 2, the perimeter is scaled by 2. But the area is in 2 dimensions. It's units squared. So you actually have to take the scale factor and square it, and that gives you the scale factor for the areas. Moving on to number 4, we have a rectangle that is 40 centimeters by 32 centimeters, and this question is asking us to scale this by a factor of 1.5, or written as a percentage is 150%, and they're asking for the new dimensions of the rectangle. So basically all we have to do is take our dimensions, take the 40 centimeters, multiply that by 1.5, and take the 32 centimeters and multiply that by 1.5, and that will give us the new dimensions. So 40 multiplied by 1.5 gives me a new dimension of 60 centimeters, and taking 32 and multiplying that by 1.5 gives me 48 centimeters. So the new dimensions would be 60 centimeters by 48 centimeters. Now, going back to the problem, the scale factor was 1.5, or 150%. This should have given you the clue that you're making your rectangle bigger because your scale factor was greater than 1. So looking at your old dimensions, 40 by 32, and looking at your new dimensions, 60 by 48, it makes sense that the dimensions are bigger. With your groups, why don't you complete this note sheet, and I will come around and answer questions, but you should have a solid foundation on how to solve for scale factors and how to apply them.